Hello, in this video, as you can see, I do very normal thing, which is I compiled Ardupilot, ran the SITL here, and connect to another computer that run Mission Planner. And as we can see, everything runs normally. So the topic in this video is what if I want my only version of Mission Planner can interact with this version of Ardupilot. In another way, I want to have my own private version of Ardupilot where you have a mission planner and I have a mission planner and I have a drone or a rover or whatever. I only can connect to this drone using my mission planner, but you cannot connect to the same drone using the very same equipment, but with your own version of Mission Planner. So I wrote a document here that discusses this requirement, and let's go in some depth here. So our goal is to have a firmware. I mean by firmware, I don't want to change anything in the firmware. I want to make use of all features of Ardupilot firmware and to use Mission Planner or Q ground control. And I want the very same setup. And I want to be able to have to make use of the newest version of any firmware or any ground control station. So the requirement is I don't need any specific or hardware requirement. No version restriction. I mean that I can use the latest version of anything, of any of the modules above. I don't want any limitation on Mission Planner. I want the implementation to be something easy. I don't want to go deep into code. I will just compile and edit very few things without giving the risk of introducing any errors or bugs to the system. Because as we know, Ardupilot is very complex, huge system, and it's not easy to change. And it's not easy to change lines in the code without testing and make sure that everything is okay. And actually, if you try to change lines, you are actually out of their version. So we need to keep everything intact as much as possible. So the first solution is just playing with the message ID in the MAVLink, because I don't want to change the MAVLink protocol. I don't want to encrypt it, because anything of this stuff needs either new hardware or changes in the software. So the pros of this is that it's easy to implement. As I said, it's very easy, as we will see here. You need to open a file and just change some IDs here. And it's safe, so it doesn't introduce any bugs, as I said. And effective, because it takes only, if you change this number to 1 to 3, it's done. You cannot access that ROM. The cons is that you will be able to detect the MAVLink traffic via telemetry. If you have a telemetry, the same channel of you will be able to detect that there is a MAVLink communication running here. But playing with the messages ID will make it hard or make it actually impossible for non-modified applications to access the MAVLink and parse it correctly, because simply they will be discarded in the CRC. Another disadvantage is that there is no encryption and there is no security here. Anyone can reverse engineer this message and gain access by, for example, he or she can study the message ID and the sequence, the rate and the content, and try to figure out what message is what. And this is not a trivial task, but it's not hard, it's not impossible, and it's not very hard actually. So again, so it is there is limited security measure here, because I'm not trying to develop something complex here. I'm just trying to give the hobbyist the feel that he has his own drone. So I'm not trying to build something very sophisticated. I'm actually, the goal of this topic is to build something easy, effective. Okay. First thing, the minimum requirement, the knowledge of programming that is needed here is to know how to build Ardupilot code, firmware, and mission planner. That's it. You don't need to understand the code itself. You just need to be able to build the code, which is not a hard task, and it is well documented here. It's well documented here, and here are the links. I will not go through these links because they are well documented. There are a lot of videos describing how to do that, so it's very easy to go through these links. Okay, let's assume now we are able to build two environments for Mission Planner and for Ardupilot firmware, and we are able to build them. Let's go to Ardupilot source code. I use here Visual Studio Code, very useful IDE. And we need to go to MAVLink message definitions. And here in the minimal, we can change this message ID. Let me use the same code. Okay. Okay, to keep everything consistent with the document, I will add this same message ID. I can make any ID. The only condition is that we don't want two messages to have the same ID. So you need to make sure when you select an ID, you don't give another message the same ID. So you need to look and check the messages carefully. For example, in common here, you can, for example, switch the ID between attitude and attitude quaternion. I hope I pronounce it well. Or scale pressure. You can switch, for example, between rope pressure and switch between scale pressure. It's now 98 and 90. It goes like that. You can play with the message IDs. Let me return back all these values to the original values. I will only keep this value changed. So the heartbeat now is this number. I chose this number because I know that it's not used in the MAVLink. I checked before, and you can easily check it using a search like this. It's not found anywhere. Okay, so let's compile the code. It's first clean, and now let's compile it. Okay, now we built successfully the code where the heartbeat message ID is not 0, is not the standard value. So we can run the simulator here. Simulator is very easy. It's very easy tool. Actually, it's ITL. It's very useful. You can test lots of things using it. Okay, I will forward the traffic to my Windows machine to port 14552. And now I will go to the Windows machine, the same mission planner, and I will connect again. As we can see, we are receiving valid data here, but not heartbeat. As we can see, there is data being received here, 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 and here. You can see data, but it still cannot connect because the heartbeat message is not there. If we continue and change it more message IDs, even this data will not be available for the mission planner. Now we got an error, no heartbeat packets received. So now we want to build our own mission planner where we can receive this modified message. Now I have my Windows machine with Visual Studio installed on it, and this is the code of mission planner. We need to go to external libraries, MAVLink, and go to minimal here and change this number to 12873. But in this case, we need to run the regenerate code in order to regenerate the C# classes for MAVLink. But since I'm changing only a single class, and since this is not run, this path file is not part of the compiled code, I need to run it manually. So I will go and change the message itself. Here it is in the mavlink.cs. Here it is. mavlink.cs here. And now I will run this code. And it fails. Why we need to know this? I kept these errors because you will face them whenever you try to do the same. For a reason I don't understand, this is a byte and we should convert it to integer here and here. Okay. Now let's run the simulator. It's not working because I forgot to change this. As I said, it's stressed. It's better to regenerate the whole code. So here the code is 12873. Now it's working. So this version now is the only version of Mission Planner that can run this version of Ardupilot because of a single message ID. So if we continue and change everything, if we even played with these values, we will confuse many ground control stations. I hope you find this video useful, and if you need to review the topic here, I will leave the link in the description. Thank you very much.